Okay, hello everyone and welcome again to the second video of the Mega Lab series in the English version for the CCNA exam 20301 number, the new one of 2020. This series, as you may have watched it before in the previous video, in the first Mega Lab, or maybe you have no idea about it. This series is all about 3 videos. Each one of them will be of big implementations of big labs with a ton of devices, a minimum of 6 up to 8 protocols in one single lab applied to all the devices, and in the end the target will be that everyone will be able to see everyone and so on. This series should have been out of 4 labs actually, and in the 4th lab there should have been a bit of management and access list skills for security, but time will never be enough because of preparation and recording for the new CCNP Enterprise, what we call it, the Encore exam, which is an exam that can participate in 2 certificates, the CCNP Enterprise and the CCI Enterprise Infrastructure. Okay, in this second lab, and actually the second goal of this series of 3 videos are to use some protocols that have been removed from the CCNA, the new CCNA course, okay? Like HSRP, SVI, Switch Virtual Interface, Router on Stick, ROIS for dynamic interVLAN routing. It's true that RIP, EIGRP, and VTP have also, BGP and VTP have also been removed from the CCNA, but those are not really that important for a CCNA guy to know. What's important for a CCNA engineer to know is actually really the HSRP, Router on a Stick, and Switch Virtual Interface, the SVI. Those 3 are really important because all the companies in the world, not all, most of them, a lot of them are still using those in their entire networks, and when they hire a Cisco certified engineer, they would expect him to know what are those protocols and how to operate them, at least how to verify, do some simple troubleshooting or implementation regarding those protocols. So it would be unfortunate if you are a CCNA certified engineer and you really have no idea about dynamic interVLAN routing or interVLAN routing protocols like ROIS and SVI, and also at least HSRP out of the FHRP family. So let's solve that. In the first Mega Lab video, you'll find it Mega Lab number 1, the English one, not the Arabic, because there are also already the Arabic videos are published since a month ago or 2. The first video discussed the router on a stick and implemented it completely. In this second video, there will be a lot of protocols. Yes, correct. Those a lot of protocols, all of them are part of the new CCNA, but the one exterior protocol that we will use that is out of the scope of the new CCNA will be Switch Virtual Interface for today. And this is will be all about how to connect, how to route or interconnect multiple VLANs if you have no router. If you have a router, then you will use a router on a stick, ROIS. If the company could not afford a router, it was a switch, then at least make it a multi-layer switch or a layer 3 switch and use SVI. Okay, today's lab will be twice as big as the previous one and twice as big as the next coming third lab. This will be the biggest one, and it will contain a lot: DHCP relay, ring topology, VLANs, SVI, Ether channel, multi-area OSPF, not a single area. You will see the difference, and ABRs, area border routers, and I hope that you will enjoy that. Okay, so let's start by building our lab or network for today. I believe that I have already disabled numbering. Yep, show port labels to start today. And I will start first with a lot of switches to build my first ring, which is in the headquarters, or actually is the first region that I live in, and as an engineer I work and operate that ring network. Okay, so that will be this way, some sort of 6 switches. Those 6 switches are 5 switches that all of them go back to the main root bridge. I will make it a root bridge if it was not, so we will manipulate spanning tree. You will see that This is extremely important for an engineer also. And since this one will be the root guy, then it will forward the traffic to the closest layer 3 or distribution switch, which will be here. Okay, so this is what will happen, is that a multi-layer switch will be here at this place, and this one does contain some gigabit Ethernet interface. Yes, that would be important. Let me do it. Options, preferences, and there are some titles that are not really the model. Yeah, the model is not important. That would be better to clear it more. Okay, so switch 1, I need switch 0 actually. Let's make it the first one, and then switch 1. Switch 2, is that really necessary? No, but hopefully that it will automatically become the root. Okay, this way those are 6 switches that will be connected in a way of 1 minute ring. So they are closed. That would make them a ring, and then spanning tree will definitely operate itself because a loop might happen here, a layer 2 loop. And since all of those are using a fast Ethernet, so the 100 megabit is traveling maybe from this way to this way, 100 megabit in this half of the ring, maybe this part. Okay, thank you. I would have to restart my annoying pen. That's like in every beginning of every lab or video. I'm sorry. Okay, now it's restarted. Yep. So the idea will be in real life networking is that this half itself could need or consume or have 100 megabit of data traveling per second. This other half might also be 100 meg, so it will be unwise to have also 100 megabit per second bandwidth or port in this uplink. This part or this link here that collects all your data of your ring and uploaded it to the main data center or distribution layer because you were in the access layer, then this link will be called the up link. Okay, and mostly if you are already an engineer and you are familiar with that, you will know that mostly more than 80% of the cases, whenever there is an uplink, it will definitely be or will definitely have a higher bandwidth or speed than the ring itself. So if this one was 100 megabit, then at least let's make the uplink a 200 megabit per second in speed, in regarding of speed. Okay, that would be cool, and that will be enough. 200 megabit, twice as the ring capacity, will be good. So we will guarantee that if there was 100 meg traveling this way, like collecting from devices here, here, and here, and going to the root bridge this way, and another 100 maybe like from this way, this way, this way, going there, then 100 again will not be enough here. So 200 megabit at least would be good. How to achieve a 200 megabit uplink? If you are familiar with chapter 2 and you have studied it, then you would know that we would definitely need an ether channel, a layer 2 ether channel. Okay, I hope it is okay. Okay, so this will be considered as a spanning tree enabled by default also. Why? Because there might a loop might happen also here. So until we enable ether channel on both those devices, it will be a spanning tree enabled. You see, one is still amber, the other guy is turned on green. So no problem until now. I have no problem. Okay, I will monitor that or I will fix that later. What will happen to that multi-layer switch is that you know that in the exam, in the course, we have always talked about design and 3-tier networks. And in 3-tier networks, you have the access layer. Those guys here, those all of them are access layer, and they are mostly or all of them are layer 2 devices using layer 2 technologies like spanning tree, VLANs. That's it. Okay, and then you have the distribution layer or the distribution device, which is this guy. With the facing the access layer, it will use layer 2 protocols here like ether channel without IPs, and from the other side facing the core, which is mostly yes a router, then it will use a layer 3 technology. So this device will be split into two halves. One will be a layer 2 talking to those people, the other one will be layer 3 talking to this master here, okay, this guy. Okay, so you will see that I will enable both layer 2 and layer 3 technologies on this device. Layer 2 like ether channel trunking and VLANs. Layer 3 will be like IP and OSPF. Okay, as simple as that, no more. Yeah, more. Yeah, a bit more. Something tricky that I will show you in this lab, but you will love it. Okay, so until now we are good. So this axis is connected to this distribution. This distribution layer should be connected to a core layer. So would you please go to the market and buy me what to make it. Let's make it a gigabit Ethernet capable device like 2911, because 2911 have 3 gigabit Ethernet interfaces, and 3560 switch also have at least 2 gigabit Ethernet devices. So I will be able to connect a gigabit interface between those two guys. This is all what's happening about from here to here so far, and I hope that so far we are clear. So this is my first ring, that contains an access layer, distribution layer, a core layer. All of that should be good. So this will be named the core of our ring 1. Okay, this should be the AGG, the aggregation of ring 1. AGG, I mean aggregation, I mean the distribution device. It's also called the aggregation. And that's it, okay, for now. The truth is that you, as an engineer, I will have to tell you some might be good or bad news, that you are responsible for 2 rings. Not just this one, another one. And the reason also, or another trick there will be, is that one of the rings will depend on another ring in something very important. You will see that in minutes. Okay, so this first ring, I have selected all the devices, access, distribution, and core, and then Control C, I click Control V. Come here, please. This is another ring that have just been operated. Don't worry, no config is there so far, so I did not take anything with it. Okay, so let's move them a bit further. This way. Let's make it, yeah, that far. Go ahead, goodbye. And let's rename it as core of R2, ring 2, and aggregation of ring 2. I don't give a care about the naming of those devices here. No problem, we can change that later. Okay, so far so good. A bit of fast forwarding, everything is green, thanks a lot. How will these 2 cores get connected? They will go back to the data center. Actually, both of them should be in the data center, and they should connect to that edge router, the biggest guy there, which is also of the same model, the 2911. The 2911 will have 3 gigabit interfaces, one for this core, the other for this core, and the third will go to the internet with NAT. That should be enough. No internet and nothing will be in this lab, because so far starting the application of this lab will take at least 90 minutes. In the Arabic version it was a complete 2 hours lab. Okay, let's hope for a shorter period today. Okay, so let's connect the last connection that I need. That will be good, and let's start the kickoff. Okay, so the first thing will be, I will have 3 VLANs that will swim over this ring or flood here, like VLAN 11, VLAN 12, VLAN 13 for this place. I hope that the text is clear. The video is already recorded in full HD with 60 frames, so I hope that you would zoom in or have a big screen. Also VLAN 21 for the second link, not the same VLANs. I will make it different because each one of them is separated. Yes, each one of them will never be able to see each other's, or they will not have a duplicate VLAN. The reason why is that there is a third layer or a layer 3 technology in the way that will cut this entire broadcast domain from the other guy, and will neglect layer 2 technologies, start dealing with layer 3 technologies. So no problem, but I will make it VLAN 22 and VLAN 23, because all what this lab will be about is interconnecting those VLANs. Okay, make it at the heart, make it at the heart. Thank you. This way. Okay, that should be good so far. Okay. One other thing will be what VLANs should flood here. VLANs should flood here. Yeah, we will definitely need the end devices to test our job. So here I have 6 switches. Those 2 switches, switch 0 and 1, will be accessed for VLAN 11. Those 2 will be for VLAN 12. Those 2 will be for VLAN 13. Here I will have 2 devices for connected to 2 switches for VLAN 21, 2 for VLAN 22, and for VLAN 23. So let's make it this way. Let's make it this way. Not you, definitely not. Let's make it this way. Okay, and for this guy here, I would like to make it away. You here, you, 3, 4, 5, and unfortunately I will have to start extending cables. I will later access them per their VLAN and see if all the VLANs will be able to be connected to all the other VLANs. And you can add 20 PC per 20 end device per switch, whatever you like, but just one will be enough for today, just to show you the example. Okay, I would like to make you here just like to be a mirror for both sides. Good. So should we start implementing? Yes, we can. Number one will be something simple, is that give VLANs, identify and create VLANs inside the switches, make your interfaces trunks between the switches, access all your interfaces in the switches that are heading to the PCs to become, come on, make it green, yeah, thank you, to make it all accessed. That would be a layer 2 job. Eliminate this guy here, the yellow thing, preferences. Let's hide something for 1 minute, and I'm talking about this. Okay, this amber color, eliminated how? By eliminating the need for spanning tree and making this, or bundling these two and these two in an aggregation bundling, or an ether channel actually, and then life should be good. Okay, so let's do that. Okay, let's start with those switches. What I will do in that switch will be is that I will create, by the way, I will have to create all the 3 VLANs in between all those 6 switches to allow the frames to travel tagged between all those 6 switches. Should I also do that in this place? No, I should not enable 6 VLANs here and 6 VLANs here, 3 and 3 for this tagging. The reason why is that there are already layer 3 separating them, layer 3 technologies between them, so no need for that. Just do 3 VLANs for this ring in between it, 3 VLANs for this ring in between it, and the trick to solve the issue I will show you in minutes. So let's start with this one. Okay, so this switch will be enable, configure terminal, create VLAN 11 and give it the name ring 1 VLAN 11. Okay, and then VLAN 12 will be ring 1 VLAN 12, and then VLAN 13 ring 1 VLAN 13. That should be good. Show VLAN brief, then you have it this way: 11, 12, 13. Of course, nothing is accessed so far. Leave it. We will discuss that in a minute. Okay, so step number 1, creating the VLANs and giving them a name for this switch. Step number 2 for this switch will be to make fast Ethernet 01, 02 as trunks. Okay, so you will notice something very important, and that will be every switch right here in this topology have fast Ethernet 01 and 02 connected to the other switch. So whenever you see a fast Ethernet and what was 01 and 02 and these 6 switches, then you know that they should be trunks, okay? Because it's just a coincidence that all of them. Let's make sure of something. Yes, fast Ethernet 01 and 02. Whenever there is a fast Ethernet 01 and 02 in this topology, then all of them should become trunks. The reason why it's guaranteed because I have started connecting them simultaneously, so I've guaranteed that all of them will be fast Ethernet 01 and 2, 01, 02, 01, 02, and in this way. I mean, okay, so let's make, okay, configure terminal. Let's make interface range fast Ethernet 01 and 2 as trunks switchboard mode. Trunk, done, yes, done, exit, and we are good with that so far. Leave it. And next, what do we need next? To access something on a specific VLAN. I will prefer to do that separately later because there will be difference in that, but at least a unified type of config is that we need to create 3 VLANs, give names to 3 VLANs, give fast Ethernet 01 and 02 trunk for those 3 VLANs. Okay, I hope that is okay for you. Okay, so let's complete that. What I've just done to this switch should be duplicated, replicated, and be done again and configured again for all those 3 devices. Will you enter or log in each of those 5 again and do the same config? Either yes or no. So it's either I take my config, leave this one, let's maximize that to understand correct. Maybe I will take those, copy them, have a notepad, paste them. I will leave config t, okay, then create VLAN 11, give it the name of link 11, and then create VLAN 12, give it the name of 12, VLAN 13, give it a name, and then do not end, make it an exit. Why? Because I will hit then interface range fast Ethernet 01 to 2 switchboard mode trunk end. How about that? Okay, just make sure that when you create a script that you will copy and paste in your entire device, this is considered as type of basic simple automation. When you have one script that you are sure of it and you will paste it in your in all of your devices, this will be much faster than logging every time and keep using the keyboard. Okay, so create VLAN 11 with a name, 12 with a name, 13 with a name, exit the VLAN mode config, enter a switch and interface mode config, and make them or change them. Okay, so that would be one last thing is that when I log in, by default it's user mode. So let's make it enable in the beginning. Okay, copy. Let's save our config here by hitting right. Okay, and let me go back to my, I'm sorry, notepad. And also I would like to save my config. Okay, so copy, log into this guy here, CLI, big screen, and just do a paste. Everything, go ahead. Okay, how to make sure of that? I will tell you. Show VLAN brief, everything is good, and show interface trunk, everything is also good. Thanks a lot. And it has been saved automatically also because we have typed the the WR and UR also. Thank you. Escape that. You see how simple is that? And we will do it to the second one also, the second ring. Yep, thank you. That would be good. CLI paste. Yes. The last one will be here. That will be paste. Yep. Done. With a fast forwarding. More. Everything is green, everything is good, everything is trunk, no problem. Of course, spanning tree will still operate whether it was trunk or access. This will not affect the looping, okay, this way. and we are done with ring number 1 just for creating. Okay, so the next step will be is that each interface here should be accessed to its own VLAN. I have to do that manually. This will be annoying. Let's do that. So configure terminal, one interface here which is fast Ethernet 05. So let's make it interface fast Ethernet 05, switch port mode access, and switch port access to VLAN 11. And thank you, and escape that. Fast Ethernet 03 here for this switch will also be accessed to 11. So config t interface fast Ethernet 03, switch port mode access, and switch port access to VLAN 11. There was another trick that would help us a lot in automation and scripting will be before I connect this switch to this guy, I should have created all the PCs and connect all the PCs here to the switches, so that I will guarantee that whenever there is a switch connected to a PC, it will be through fast Ethernet 03, which is arrange them simultaneously. Okay, that would make it easy because we could have added the script of interface fast Ethernet 03, switch port mode access, switch port access VLAN, such thing, and we will just change the number of the VLAN every time and keep pasting the commands. You can do whatever you like. You can print it all manually by yourself to strengthen your skills. Whatever you like, you can do it all. Okay, so this one will be for VLAN 12, these two switches. Interface fast Ethernet 03, switch port mode access, and access to VLAN 12. I would like please to copy it because it will be identical to the next switch, also fast Ethernet 03, and also this one. Oh, thank you. So now Backtracer copies everything without using its plane. Okay, I'll do it myself. 03 to VLAN 12. Okay, and for these two guys, they should be on 13. Also 03 for both of them. Good coincidence. To VLAN 13 and the end. Okay, so far so good. Bit of fast forwarding will make everything green again. Thank you, thanks a lot. We are done for inter-VLAN, the inside of the ring working. I hope that this was good so far. There is someone out there shouting. I hope that you are not listening to her. Okay, so again, VLANs have all been modified and created with names. Good. And then what do we need more? What do we need more? We will need, I will tell you. VLANs have been accessed correctly. This port here should be solved also. To make that will be by making it, this one as an ether channel. I'm sorry, I forgot what to do. 1 minute. Okay, I will make these two as an ether channel by using LACP, of course. So let's go ahead here, and this will be fast Ethernet 02 and 01 connected to, what have I done? 1 minute. This gig is connected to a fast Ethernet. Take it, connected to gigabit Ethernet. Yes, I'm sorry. And let's check the numbers. So that will be 1 minute. Yes, from this switch it will be 0, 3 and 4. From this switch it will be 1 and 2. Okay, from here I will also have to fix that big issue by changing this to a gig, and just to make sure, again, this one will be 3 and 4, this one will be 1 and 2. Okay, no problem, that should have been fixed right now. Okay, so let's go to the CLI of this switch and let's create an ether channel. So no, definitely no again. Yes, enable configure terminal interface range fast Ethernet 01 and 2. No. And let's make it it will stay as a layer 2. It will be a trunk, yes, but let's create the channel group 1 mode active, and that is good. Exit interface port channel 1 switch port mode trunk. How about that? No, we cannot because it's an auto, so we will solve that by typing switch port trunk encapsulation.1q and then mode trunk. And what I have just did is that by default this multi-layer switch have these interfaces set to trunk auto mode, just like the LACP auto mode that does not accept to become a LACP port, an aggregation port, unless another port start negotiating with it, just like the passive. So what I did is that I forced it to make it trunk by force encapsulation, and then I make this interface trunk. So as simple as this interface, these two interfaces have been bundled in one, and that one was turned to trunk. As you have noticed that I did log out or exited the physical guys interfaces, and then did interface PO1, which is the port channel, and apply the trunk options or config there. This is very important in Cisco. Okay, for the second one, the same commands copied and pasted, but just change the numbers of the interfaces. Configure terminal interface range fast Ethernet 03 and for channel group we can make it the same number, no problem. One mode, either passive or active. I would like to make it both active. There's some misprinting here. ROUP, yes, active, done, good. And then there's some catastrophes happening. I will do that as fast as I can because I should exit and hit interface PO1. I should have disabled the interfaces before doing all that, and switch port mode trunk. That should solve the issue, and it will not, I'm sorry, maybe fast forward. Good, that will solve everything to become green. Come on, yes, 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 finally. Okay, so no spanning tree here again, not anymore, because this is a single 200 megabit interface, which is called PO1 from this side connected to PO1 from this side. So as a layer 2 technologies, now I'm done. Now I'm certified. Now I have no problem with layer 2 technologies. So far so good. Okay, and how about to do the same to the other ring, or at least let us operate this ring, troubleshoot it, try to do some pings between the devices, try to reach another broadcast domain. If everything works successfully, then we will copy the same commands, change some things, modify them, and paste them here. Okay, so right now, how to obtain IP addresses for your PCs? Now, right now, we will have two challenges. Challenge number one will be each VLAN here, we have three VLANs. For each device, you will have to specify a gateway to allow those different VLANs to communicate between them or between themselves. How will that be? In the previous video, we needed a router here, and we have used the router on stick method by specifying sub-interfaces in the interface of the router and gave those sub-interfaces IP addresses, which were the default gateways for each VLAN, and later those VLAN could communicate together. Okay, in this video we will use what's called the SVI, the switch virtual interface. This is using some type of hybrid solution, which is creating something called interface VLAN. That will be a logical interface that resides inside a multi-layer switch, just like a loopback in a router. There will be an interface VLAN that resides here. This interface VLAN will also have an IP address and will also become a gateway for a specific VLAN. So I will create three logical interfaces inside the multi-layer switch. Each one of them will be a default gateway for a VLAN. Later, I will give the IP address of it as a gateway for those guys here. All the six of them, all of them will have a default gateway heading to this logical device in here, because this interface is trunk, this interface is trunk. It will reach all the way up there. and will hit its gateway, and that will be good enough, and they will route between themselves, and all of those devices will be able to see each other. It will be very simple creating commands. I will show you that in minutes, and that will be good. Okay, so let's create some VLANs, some interface VLANs. Okay, so what do we have? Let's have a label, and that label will make it for VLAN 11. We'll have the network of 10.10.11.0/26/27 will be good. Do not waste a lot of VLANs because we have a few number of devices. And for VLAN 12 will be 10.10.12.0/27, and for VLAN 13 will be also 10.10.13.0/27. Of course, I will make all the .111 as the default gateway for them. Hope this the up screen is clear for you, and I will start creating the default gateways, which are the interface VLANs, or we can call it, sometimes it's referred to as layer 3 VLANs. Okay, so config t host name, I will change the name of this device as the aggregation of ring 1. That is cool. Interface VLAN 11. I've created an interface VLAN. What can we do? We can give a description or give an IP address. Okay, so IP address of this one will be 10.10.11.1, and that will be /27. Exit, exit, as simple as that. That's it. Just give an interface with an IP. This will automatically be the gateway for those guys. Of course, you'll have to type the same IP in the GW here. Okay, so interface VLAN 12 will be 10.10.12.1, and exit 3 times up 13 will be 3 times up 13.1. Exit, another exit, and end, and show IP interface brief. You can see below I have 3 new interfaces that, like every time, I forgot to hit no shot. I should have done a no shot for those devices, for those interfaces. Yes, so configure terminal interface. Is there something called range VLAN? Let's try this one. No shot, and did not work. No, I think it should work because show run. How about we do that manually again? Interface VLAN 11, no shot, and show IP interface brief. If it's still, yeah, then the command will work later. No problem. Just we should give an IP and no shutdown. Should be good. No worries. It will work later, and you will see that in minutes. Okay, so right now we are good. I have created those 3 interfaces here. They are logical interfaces right here, and there is something that I have forgotten to do, and that will be very important, very important, very important for configuring and troubleshooting. And this will be creating interface VLAN 11. This switch is good, but this is a multi-layer switch. It's a switch. It was born and created as a switch, so it does not really understand an interface VLAN before it understands the VLAN. So we will need to create VLANs themselves, the layer 2 VLANs first, and then to create an interface VLAN, which is a layer 3 VLAN. And I believe this is why they are still down. So the idea will be configure terminal VLAN 11, not just an interface VLAN 11. You see, now the interface VLAN 11 is up. Yeah, I should have done that before. Okay, let's give it the same name. We can make it the same name. A name, what was it? Ring 1, maybe it was V11 or such thing. Yeah, no problem. And then let's create VLAN 11. Up is also, and give it a name, and VLAN 13. Yeah, so it will be a no shutdown, and also create a layer 2 VLAN. So end show IP interface brief. Everything is up. right now. That should be awesome. Okay, do you have any problem so far? I hope not. You have the comments below and you can pause and navigate the video if you have something to miss. Okay, one last thing, how to make those devices have an IP address subnet mask and a gateway so that they would head to their gateway and they would have that routing between them. We can give a static IP address just like we did in the previous lab, but no, I will do DHCP today. How to do DHCP will be very tricky because you will have three VLANs, three different broadcast domains. All of them requires IP addresses from different pools. So yes, I will create three pools inside this multi-layer switch. I will make this multi-layer switch behave like a router. I will create a DHCP, three pools of DHCP. Each pool is different in IP address, gateway, maybe in subnet mask and DNS and so on. And let's see if those devices will receive a correct IP address from the desired pool. Okay, that will be based on the access ports, of course. And let's check our work. Okay, so right here I will hit config IPDHCP pool, and the pool will be v11 for VLAN 11. The network will be 10.10.11.0 and it will be a slash 224/27 and give a default gateway to VLAN 11, which will be 10.10.11.1, which is the IP address of their gateway here. Good. And give them a DNS. Let's make it the Cloudflare DNS. That will be awesome. Exit. And I will replicate the same commands again for creating another pool and making that 12.0 and making that 12.1. It's not that difficult. DNS server. Exit for 13. Also 13. Also 13. The same DNS for all of them. Exit, and something very important will be to exclude the gateways so that they will not be given to anyone. 11.1, 12.1, 13. And I believe that I could specify another IP. Yeah, it will be a range. Okay, no problem. Then I'm done. Yes, as fast as that. Yes, that was very fast. And let's see this PC if it will receive an IP address from pool 11, not another pool. Okay, so an IP address, DHCP option, and let's hope for the best. Successful from 11.2 and the gateway is 11.1/27 and the DNS will be 1111. Okay, another PC should also be on VLAN 11. Let's see. That will be 11.3 with the correct info. Let's see if the two guys from VLAN 12 will also behave correctly. Correct, 12.2 with the correct gateway, and another one will be 12.3. Thanks a lot. This one here will be 13.2. Thank you. One last device to check. Hope that we are making use of all that work. Will be 13.3. Awesome. Right now in this ring, all of my devices have IP addresses, the subnet mask, a correct mask, a gateway to reach their gateway, and that should make them able to communicate together. Let's see. Let's try our luck and let's try to ping PCs from the same VLAN and from different VLANs. Let's see. Ping 10.10.11.3, which is the other PC near to you. Ping correct, successful, no problem. Ping a PC from another VLAN. Let's see. Will that work, or should I need to enable some feature that I did not enable? Let's see. Let's see, please. This means that my PC here, right here, this guy that have 10.10.11.2 is trying to go to its gateway here and asking it to pass to another gateway, which is this gateway of this VLAN, so that it will lead it to this other PC. this passing between an interface VLAN and another interface VLAN, this connection between two broadcast domains is not happening, unfortunately. And the reason why is that this switch, this multi-layer switch, is still behaving as a switch. I will need further to make it behave as a router. How to do that? By config t IP routing. Just enable the routing core inside this switch. Okay, so routing will start to operate. Once again, try to ping the same address of a few minutes ago, and let's see the difference right now. Okay, .12.2, and hopefully that will fix it. Timeout, ping, ping, and ping reply. Good. Okay, one last try. Let's make it 13.3, which is the PC that resides here, and let's see if 11 can communicate with 13. Will it ping? Yep. Okay. Okay, so far so good. I have a small enterprise network that contains a ring topology of 6 switches, a ton of PCs if you would like, and servers and IP cameras and IP phones and printers, whatever. And all of them are on 3 different VLANs, but they can communicate with each other. So far so good. Okay. So if this one did work successfully and they did obtain IP address through DHCP, then how about we do it to the other guys, to this other side? Okay, how to do that will be I will copy the same commands. We will not do that big like those big efforts of like commands or configure. We will do a lot of copying and pasting, and let's see what might happen. Okay, so let's have it this way. I will need in my notepad again, and let's start study this case. Okay, each switch of those 6 switches I will log in conft, and I will start to create VLAN 21 and make it ring 2 VLAN 21, and I will create VLAN 22 and I will make it ring 2 VLAN 22. This is very important. And then 23, and give it the name ring 2 VLAN 23. Interface range fast Ethernet 0, 1 and 2. Yes, it's a coincidence, but all of them are fast Ethernet 0, 1 and 2. Trunks and right. Okay, and another thing will be before ending, how about to add the access thing also, since all of them have PCs connected to fast Ethernet 03, and only this guy have its PC connected to fast Ethernet 05. So I will fix that by doing something very simple. I will delete this link for a minute. I will take this cable and I will connect it again to fast Ethernet 03, and I will have another cable connected here, so it will be 4 and 5. Good. And 3 will be for the PC. So all of these 6 switches right now have fast Ethernet 03 access to a specific VLAN. What VLAN will that be? I will change that. Okay, so this will not be an end, it will be an exit. And interface fast Ethernet 03 switch port mode access, switch port access to VLAN something. It will be 21, 22, 23. I will have to change the script in every time. And what do I need more? What do I need in a switch? Create VLANs, give name to VLANs, make some ports either access or trunk. Done already. That's it. Yeah, that will be that's it. Okay, so this switch and this switch will be to VLAN 21, these two for VLAN 22, these two for VLAN 23. Okay, so I will apply this command or this config to these two here. So copy CLI enter and paste. Clear the screen, paste. All done, no errors, no errors, yes, no errors. Let's verify this first switch. Show VLAN brief. Yes, 3 correct VLANs were created with names. VLAN 21 have fast Ethernet 03 access to it. Good, correct. Show interface trunk. All good. All good. Then write to save the config. Okay, head to the other guy. CLI. Make it big. Hit paste. What happened? Okay, no problem. I will do it again. Paste. Yes, everything is good. End and write. We will need to add end and write to our script. Okay, and make it this way. End and then write. Good. These two are done. I will have to do these two, but these two should be accessed to VLAN 22 this way. And copy, login, CLI, paste. Have a disaster. Something is not working. Why? What's wrong with you? I have done something wrong? No. Copy everything and Control Shift 6. What are you doing? Control Shift and 6. No. Will not work in Backtracer. Okay, how about we will go to this switch, CLI, hit enter, hit space. Ah, good. And then go back to this switch, big screen. You are very annoying. I will reboot the switch. It's really annoying since it already have no config. So we can reboot it. No, we cannot. There is no power here. There's some type of layer 2 issues happening to this guy. Control F6. Nothing happening. Okay, this is wasting of timing because it's doing a script should have solved the issue. Yes, finally. Paste. Thank you. Good. Show VLAN brief. Yes, it's success for VLAN 22. Good. Escape that. Go back to the script. And I will access to VLAN 23 for the last two switches here. This one and this one. So this switch, big CLI, and paste. Done. Access to VLAN 23, I hope. Yes, this one right here. And escape this one. CLI. Paste. Thank you. Okay, we are done with 6 switches. That was fast without this annoying guy here doing some things. Yes, only one port is blocked because of spanning tree. And done. Okay, so no further job to do in those switches at all. Next, or actually something is ether channel. I will configure ether channel here, but I will be more careful than the last time by disabling first. The best practice will be to conft interface range fast Ethernet 0, 1 and 2 shut down, please. That will be very good. Okay, just shut down, enable LACP on both devices, and then no shut. Would be much better to avoid problems. Okay, so channel group 1 also mode active. Yes, created. Exit interface PO1 switch port mode trunk. Okay, it's an auto. Again, switch port trunk encapsulation .1q trunk end. Done. Let's go to the other side, do the same thing, and then to enable the same devices, the same interfaces. Configure terminal interface range fast Ethernet 0, 4 and 5. Channel, it doesn't matter to match the same number. I can make a channel group 2, whatever you like. It's the name of an interface only. I can make it either active or passive, no problem. Create it successfully. Interface PO2, switch port mode, trunk, end. One last thing is to come again to interface. Let's try PO1, no shutdown. Will it work? No shut. Oh, thank you, because the physicals are down. Yeah, if I disable the PO1, that I can enable it later by enabling PO1, but just because I did that with the range fast Ethernet 0, 1 and 2, then I will have to unshut those. Thank you. End. Okay, change state to up. Don't care about this thread, no worries. Give it 2 minutes. It's not really flapping, it's just indicators of the packet tracer. Everything is green, no problem. Yes, I did. Oh, yeah, that's good. That is good so far. And how about we head to this device and create the VLANs and the interface VLANs and make them the gateways for this guy. And let's do it this way. No script is really needed. It will be simple. Configure terminal. Host name will be the aggregate device of R2, and start creating VLAN 11. You can name it later. Done. Interface VLAN 11 will be an IP add of, we did not specify something really. Let's make it this way. Let's make it for VLAN 21. Did I type 11 there? I will delete it. Yeah, God, what have I done? I will delete it immediately. Okay, let's make it 10.10.21.0/26, and the VLAN 22 will be 10.10.22.0/26, and VLAN 23 will be 10.10.23.0/26, and I will take it to this edge right here. That should be clear. Go back and delete those 3 incorrect VLANs. Exit. No interface VLAN 11. Yes, this is how to delete it. No VLANs 11 to 13. Oh, you cannot accept range, you annoying guy. No 11, no 12, no 13. Do show VLAN brief. Yes, clear. Nothing more is there. Good. So we will have to start again by creating VLAN 21, 22, 23. And interface VLAN 21 will be the IP address of 10.10.21.1 as a gateway, and that will be /26. Good. Create VLAN 22. Thank you. 22. Should I do no shot? I will check that in minutes. And create 23. And let's see .23.0. I am done. Do show IP interface brief. The do will allow me to show something in the config mode, so that will be up and up. No need for a no shutdown. I was mistaken previously. Okay, up and up. Everything is up. Everything is cool. No problem. Good. So just in case one of those devices got an IP and a gateway, it will be able to reach its default gateway, but it will not route because I did something again, and you should right now be able to remember it. That will be IP routing. Good. Okay, so far so good. I hope it is. We are about to reach 1 hour of working. This is about 80% of the lab. Yes, we have done it in a really fast way because of scripting. And what's happening to this interfaces? Why are they amber? Is there some logs here? No. Any logs here? No, nothing showing as error or emergency. Okay, no problem. Good. The trick of this lab, the second trick, the first trick was the SVI, and it's done right now. You can see that it is a gateway for VLANs without a router needed. The second trick will be I will not configure DHCP in this multi-layer switch. Never. Never, ever, ever. I will not configure DHCP at all here. What I will because this is a far ring from another region, and this type, maybe this is a cheap switch that cannot handle DHCP. This is a very expensive model that can do that. I will create the 3 pools of these devices here, and I will have to use DHCP relay for 3 different broadcast domains that will take the broadcast messages of all those 3 VLANs and pass it from this interface up to this path this way, reaching this interface. So yes, I will have to enable routing, OSPF, protocols, subnets, addresses so far to make this switch be able to ping this switch, and later I will enable DHCP relay and some extra pools here. So we will leave that to the end of the lab. What we will do here is that to make use of those paths. This interface will be a layer 3 interface connected to the core, connected to this way, connected to this way, connected again to this way, all of them no shut, with some OSPF, and let's see the difference. What I will do is that there will be an IP address here and here, and both of them will be activated for OSPF area 1. There will be an IP address here with the region, which was the edge router, and that will be OSPF area 0. There will be another one here connected with OSPF area 0 also, and there will be area 2 of OSPF between ring 2 and the core of ring 2. So that will be the backbone area that contains 3 routers. One of them is the edge router, 2 of them are ABRs, area border router, and they are ABRs because they connect area 0 with area something. They should connect area 0 with another area. ABR is not a router, an OSPF router that connects area 1 and area 2, area 12 and area 60, never. It connects area 0 with something else. This is extremely important. Okay, so this is an ABR connecting area 0 and 1. This is another ABR connecting area 0 and area 2. So this also have been deleted from Ccna. This is not hard or difficult at all. It's not something really annoying to have a multi-area OSPF, but the blueprints were clear. Configure and verify, implement and verify, or whatever in the blueprints was a single area OSPF, like only using area 0. Okay, this is a multi-area and you will see it very simple. Okay, so let's start by planning some subnets. I will plan for the subnet here. It will be /30 to avoid exhausting subnets. Let's make it 192.168, and since this one is area 1.1.0/30, okay, for this connection here between these two guys, and for the second connection between these two guys will be 192.168.2.0/30, and that will be here. For this connection of the core, let's make it a different third subnet specifically for the data center. Will be 172. This is how you distribute and plan your networks and design your network. Whenever you see 10 something, this is inside the town, the city. It's an IP address of a device there in the access layer. Whenever you see 192, this is a layer 3 connection between the aggregation and the core. Whenever you see 172 something, then this is an IP address that resides inside the data center, and this is how you verify or how you eliminate the scope of troubleshooting and focus on single area of troubleshooting when something happens. Okay, .16.1.0/30 for this link that's gathering area 1 and area 0, and this other link here will be 172.16.2.0/30. Let's make it up this way. Okay, let's start OSPF and IP addressing with this guy here. Okay, IP routing is already enabled in this multi-layer switch. So enable, configure terminal, interface gigabit Ethernet 01. It's a switch interface, so I will have to make it a no switch port and later give it 192.168.1.2. 252 will be the /30. No shutdown is not needed because it's a switch. In this multi-layer switch, you will need no switch port. In a router, you will need no shutdown. Case is different. Okay, exit. How about I enable OSPF right now without coming back later? So router OSPF number 1, no problem with the process ID. I will advertise what every single broadcast domain that participates inside this router or this multi-layer switch. So I have 3 networks besides in the access layer and 1 network on the right side, the right arm of this left side or left arm of this multi-layer switch. So 4 networks should be advertised in this OSPF, all of them inside area number 1. Okay, so network 10.10.11.0, subnet 25/27 will be 255 minus 224 in the end. I hope that you have more skills of subnetting by studying the course and Mega Lab number 1. I have done that as a billion times before. So that will be dot 31 participating in area 1. Good. And 11, 12 with the same subnet mask and area, and 13, and also network 192.168.10/30. Yes, this will be dot 3. I'm sorry, also in area 1. Done with OSPF, done with IP addresses. I should not go back again to this router, will I? I'm sorry, to this multi-switch. Yes, I will, but not in subnetting, in a trick that I will tell you in minutes. The first core, this will be an ABR connected to 2 different guys. Let's see how to configure an ABR and how difficult will it be. It will not. Enable config T. Hostname of this device will be the core of ring 1. Interface gigabit Ethernet 00. IP address will be 192.168. I'm sorry, 1.1. And of course here we will need a no shutdown. Everything is green, thanks a lot. Another interface will be, I'm sorry, don't be that rush, gigabit Ethernet 01, and the subnet will be from this, as you can see, 172.16.1. Either 1 or 2, whatever you like. Let's make it all once here, and that will be slash this way. No shutdown will not work because we will need the other guy also. Exit. And OSPF. Okay, so router OSPF process ID can be mismatched 1, 2, whatever. Let's make it unified. Then what to advertise? On the right hand side I will have network, this network this way, that resides in area 1, and network 172.16 also /30, but it resides in the backbone. That single command line tool had identified that this guy is an ABR because it has 2 networks, each one in a different area, but one of them of course is in area 0. Okay, so and nothing really needed anymore, and I don't believe that I will ever log in here again, either in those 2 later. Okay, I hope that's okay. I hope that all of you are making good use of this lab so far. We are almost done. Interface gigabit Ethernet 00, an IP address of 16.1.2.252, and please no shutdown will make it a green. Interface gig 01, an IP address of 16.2.2. I will make it 2's here, and once on that other side, it's a design based upon your opinion, and no shut will do nothing because the other guy should also do that. And exit, and OSPF. What do I have to advertise here? Whatever on my left and right side. 172.16.1.0 will be in area number, you remember the lines that I made? Okay, and as simple as that also. Okay, 2 networks, both of them resides in area 0. Okay, then end Both of them are configured, and let's save our settings so far. One last router from the router guys to config, which will be enable config t. I have forgot to rename this one to make it an edge router, no problem. A host name will be core of R2. What do I have to do? Yes, interface gig 01, an IP address of 72.16.2.1, and a no shot. Thank you. Exit. Interface gig 00, an IP address 92.168.2. Where am I? Let's make it .1 here. Let me make it .2 there. No shot. Yes, no shot. And since it's a switch, the other side that will automatically be done. OSPF router, OSPF. Let's advertise 72.16.2.0 in area. Very important right now. 0, and the other network it differs right now. That will be in area 2, making this router as a border router again. If you wait a bit of seconds, there will be no neighbor adjacency here because it's connected to this one. There should be neighbor adjacency. Let's see some show IP OSPF neighbor. Yes, it's two-way with this guy here, this one, through gigabit Ethernet 01, and still two-way. Come on, this is not a DR and a BDR. This is a point-to-point. OSPF is very slow. If it was EIGRP, then it would definitely be done by now, because it was 10 times faster, not just 10 times. You are still stuck. Come on, still two-way, and in 1 minute it will become full. No EX start, no exchange, no loading. It will suddenly just become full. How annoying you are. Let's see what does this one says. Can I see it's full? The other side with 1.1, but with this one it's still. Come on. Done. Full. And in 1 minute, just two-way become to full. This is a backtracer issue, no worries. This is not a real life issue. Okay. OSPF. One guy is left for OSPF here, and that will be give an IP address first. What was the name of this one? Who is up here? Yes, gigabit Ethernet 01 is up. Okay, so this interface is gigabit Ethernet 01. So interface gig 01, just an IP address and some OSPF. That will be 192.16.2.2. Yes, how about no? Yes, I'm sorry, because no switch port and then the IP address. Exit, I have forgot to do that. And advertise all of your networks in OSPF. All of them resides in area 2. 3 networks from the access layer, which are those, and 1 network on the right side. So that will be 10.10.21.0 to 192 will be 63 area 2, and 22, 23, and network also in. I'm done. I will save my config. Yes, I am done. Bit of fast forward. Right now, if this multi-layer switch can ping this multi-layer switch, this interface specifically, which is 192.168.1.2, am I correct? Yes, 1.2. Then I will be able to enable the DHCP relay or the IP helper address commands, which is the last step that we will do today. Okay, so let's try our luck. ping 192.168.1.2. Yes, 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 yes. 5 out of 5 are pingable. So this one, show IP route. Let's see the routing table here. It can reach the far network of 192.168.1.0. It is a /30. Actually, we can reach it by using OSPF through this interface and this next hop. Thank you, thank you, thanks a lot. And it can reach the 3 far VLANs and the 3 close VLANs. You see how brilliant and enjoying this one. I hope that you are enjoying that also. Okay, good. So one last thing will be to create 3 pools here and to have the DHCP relay to forward the broadcast message to those 3 pools here. Okay, go ahead, go to the switch, and let's do the 3 new pools of those far guys. Config T IP DHCP pool 21. We can change the name later, no problem. The network will be 10.10.21.0 and it will be /26. The default router of them should be 10.10.21.1 and their DNS should be Cloudflare. Thanks a lot. Done. Exit 1, 2, 3, 4, 5. Make it 22. 1, 2, 3, 4, 5. Make it 22. 1, 2, 3, 4, 5. Make it 22. You see, it's not that hard to create 3 pools. 23. Done. That's it. I'm done. Okay. If you have watched chapter 4, then you know what a DHCP relay and an IP helper address is. But the question will be, IP helper address or DHCP relay is receiving a broadcast message of DHCP discovery from a device here, and once that broadcast message hits a non-broadcast forwarding interface like a layer 3 interface, then that layer 3 interface should use the feature of relay to forward it to some specific well-known IP address, which is here. So where will I apply the DHCP relay command? That is the extremely important thing. Should I enable it on those 2 physical addresses, since they are the first addresses to receive ports to receive this message, or on the PO, or they are layer 2 interfaces, so they will forward broadcast message anyway? I should enable it on this interface here, because this is a layer 3 interface that has an IP and can communicate this IP. No, no, and no. I should enable it on the 3 logical layer 3 interface VLANs. Those 3 that resides here: interface VLAN 21, 22, 23. Whenever a message, a broadcast message coming from VLAN 21, it will go forwarding to its gateway, which is this one, interface VLAN 21. Interface VLAN 21 then should forward the broadcast message all the way up to this IP address here that will connect it directly to the pools. Yes, so I will have to come to this switch and say the next command, and hopefully that it will work. Interface range VLANs 21, 22, 23, IP helper address forwarded to this IP address here, which will be 192.168.1.2. One single command should solve a ton of problems right now, and let's see if any of those devices will receive IP address. Okay, let's start with VLAN 21. Cross fingers and requesting. Yes, successfully, finally. 21.2/26 with 21.1 as a gateway and the correct DNS, another one. I will make sure of all of them, and I will ping everything, and I will celebrate this night. Let's see. This is from 23. Yes, this one. These two are from 23. Yes, that is correct. This guy should be from 21 also. Okay, let's see if it will receive from 21. 21, and the gateway is 21. Let's go to this one. This should be from 22. Please, please, 22.2. Thanks a lot. This lab will be finished in less than 90 minutes, and the previous one required 120 minutes. Yes, correct. One last PC to check, and let's see our luck. Our hard job, actually, hard working, not just luck. Good. So now all the PCs of 6 different VLANs, 6 different PCs of 6 different VLANs in different regions and rings and OSPF areas have IP addresses. Will all be able to ping each other and reach. Let's choose you. You are the chosen one. .21.2. I'm sorry, and from the command prompt I will start pinging. Okay, ping your neighbor has the same VLAN. Correct. Pinging. Ping another guy near to you from another VLAN in the same region or the same ring. First one seems to be timeout, but the second one should work. Come on. Yes, yes, thanks a lot. That's brilliant. 3 dot what are you doing? The 3.3 will it ping? First one should be timeout, and the second one should be a reply. Thanks a lot. I appreciate that. How about pinging some guys from the other part of the world, from the other ring? Will be .11.2. Ping, immediate ping. Thank you. .12.3. Ah, come on. Don't be annoying. Timeout. Oh, good, good, brilliant. That's it. And one last check for today will be from the 6th VLAN, and will it ping? Please. Timeout. Reply. Yes, reply. Yes, and reply. And yes, a third reply. If I did it again, then the replies will be from the beginning, and the percentage will be 100% successful ping. Yes. How about this lab? You like it? I hope that you did enjoy it. I hope that it was good for you. Let's color our rings with some light colors, like this is a light color for this ring. Those guys here, this is a circular ring, and another light color like pink for this ring here, this way. And let's have some areas. I'm sorry, this is, yes, this one, this shape. Let's have some areas. Let's make it a third colored ring. That should be green, or I would like to make it a blue from here to here. That will be area 1. Okay, and how about area 2? How about we organize a bit more? Yes, that would be area 2. And finally we have to organize area 0. Let's know what are we doing. Yes, I haven't used any green color so far, so it will be starting from this place up to this place. That will be area 0. Okay, we are done for today. Yeah, those are really annoying colors, not really comfort for the eye, but anyway, so we did for today, we used some ring topology. This is number 1. We did use a lot of VLANs, and we did connect those VLAN by using the switch virtual interface. We used ether channel today in both of the rings. Also some DHCP pools. and some DHCP relay, very important. OSPF, but that was a multi area. OSPF, am I missing something? DHCP relay, SVI, access, trunks, everything. Yeah, that should be everything. That should be everything. Okay, so this is almost 90 minutes or 85 minutes. I hope that you did enjoy this entire lab. I hope that it was beneficial for you. I hope that everything is really clear. The area of comment is always available below this video. And I also hope one last thing is to see you in Mega Lab number 3 coming very soon. Okay, thanks a lot for watching and see you again. Goodbye.